This video deals with the pH scale. As you can see in the figure over here at the left, in day-to-day life and in human physiology, we can encounter fluids that have an enormous range of possible proton or hydrogen ion concentrations, with that range extending from almost 1 mole per liter all the way down to almost 10 to the minus 14th moles per liter. With the higher the proton concentration is, the more acidic we say the solution would be. Now, communicating relative acidities using actual molar concentrations could be very unwieldy. So back in 1909, the Danish chemist Sorensen proposed a unitless scale, the pH scale, with numbers ranging from 0 up to 14 that could be used to communicate the relative acidities of various solutions. The trick to understanding Sorensen's scale is to look carefully at the way pH is calculated. pH is the negative log of the proton concentration. What this means is, if you have a solution with a really high proton concentration, like here, the negative log of a big number gives you a small answer. Look at the pH that we get there. Very, very low. The converse is true also. If you take the negative log of a very low proton concentration, like down here, the higher the pH value is going to be. Look down here. Very low proton concentration, a pH right up at the max. Oftentimes, to give people a foothold in understanding all of this, we define pH 7 as neutral, and we say that as pH drops below 7, especially as we approach 0, the more acidic the solution is, and as we increase pH, especially as we get up toward 14, the less acidic the solution is, or if you will, the more basic or alkaline the solution is. So let's go ahead and apply this to human physiology. Let's take normal blood in a human. The range of pH there is typically 7.35 to 7.45. The body will work hard to keep the blood pH within that normal range. You may say, well, 7.35 to 7.45, that's only a 1/10 of a pH unit difference. That's not significant. Well, yes, it really is. Because if you calculate the proton concentration that corresponds with pH 7.35 and compare it with the proton concentration that corresponds with pH 7.45, there's a decrease of 21%. That is pretty substantial. Now, if blood pH drops significantly below 7.35, we say that the patient has acidosis. If the pH climbs significantly above 7.45, the patient has alkalosis. You may think, okay, well, how far can we stray below and above those pHs and still be compatible with life? If pH drops below 6.7, or if it climbs above 7.7, most likely the outcome is going to be fatal.